here our lesson is the motion in a straight line. So here, what is the displacement and distance at the beginning? I hope you can remember it. Can you remember what is the difference between distance and displacement? Can you tell me?
This displacement has a direction and a magnitude, but distance has only direction.
Yeah, good. Distance has a magnitude only, and displacement has both magnitude and direction. So then we were discussing different examples about this displacement and distance.
Yes.
Later on, we moved into some questions, and then we were discussing about scalars and vectors. Here it is same as the distance and displacement. Scalar quantity is a quantity that has only magnitude. As you told. Or, yeah, as you told for distance. So here vector quantity, it has a magnitude and a direction. Good. Then we were discussing about speed and velocity. What is the vector quantity here? What is the scalar quantity here?
Velocity is the vector quantity and speed is the scalar quantity.
Yeah, good. It is the scalar and velocity is the vector quantity. So here, velocity is the rate of the change of displacement. Speed is the rate of the change of distance. And then we were discussing about some questions and how to calculate the speed and how to calculate the velocity. So here we learned that we can find the speed by dividing the distance traversed in a particular time. Yeah. The units of the displacement or the unit of the speed is meters per second. Meters per second, yeah. If not, we can use another units like kilometers per hour in that way. So here it is mentioned as miles. I told you that it should be kilometers. Yes. And then we were discussing about the velocity. Here we have to mention the direction where it was moved to. And then we came to constant or uniform speed and average or mean speed. That means constant means in each time interval, it is traversing or it is traveling a same distance. That is the uniform speed or constant speed. Then what is the uniform velocity or constant velocity?
2.
Yeah. Uniform velocity or constant velocity means? Can you comment on that? What is the feature of that? Velocity is uniform. That means, can you tell me a little bit about that?
Teacher, you're not clear, teacher.
Can't you hear me well? Can you hear me when I am speaking loudly like this?
No, teacher, you're breaking up.
Here it is raining little bit. I think it should be a signal problem. Isn't it clear well?
Now okay.
Yeah, it's fine. So I was asking, what is the meaning of constant or uniform velocity? Can you tell me?
Teacher, can you explain that again?
That question, that means, do I have to ask it again?
No, teacher, can you explain the answer?
Yeah, it's fine. I tell that Then you can remember it like this. Constant or uniform velocity is a same distance is traversing same velocity, this same displacement is doing at each time interval. That means if we take 1 second, it is going particular, assume it is 2 meters, the displacement is 2 meters in first second. And in the second also, the displacement is 2 meters. In that way, the displacement done at each time interval is same. Yeah, that is the constant or uniform velocity. And also we have to mention what is the direction is. So then we have a new friend, so we have to talk with her. She's still joining. We can, yeah. Hi, Umali, can you hear us? Hi, Umali, can you hear us? There's a signal problem with her side. Fine. Okay. Then after that, constant velocity and constant speed, we were discussing about constant or
uniform velocity.
Uniform velocity. Yeah, constant or uniform velocity. Then we are going to discuss about mean or average speed. Mean speed, if not the average speed.
Speed.
Here, the meaning of that is we are traversing different distances at different time intervals. That means at first second we are going 2 meters, at second we are going 2 meters, and another second we are going 4 meters. In that way, we are changing the speed. We are changing the distance we travel at a particular time interval. So here we have to take, we can see some few different speeds. So here we have to take the mean or average speed. To find the mean, what should we do?
Total distance over total time duration.
Yeah, we can divide the total distance by total time duration. So here it should be, yeah, total time duration. Here it should be mean speed. Yeah, here. Mean speed or average speed. So we got that. We took all the distance and divided by the total time duration.
Sure.
That is the mean or average speed. And then we were discussing about mean or average velocity. Here, everything is same, but it has a direction. That is the thing. It goes, if it is a car, it goes on a straight line along a path to a particular direction. At first second, it goes 2 meters, and likewise, it is going different displacement. It is doing different displacement at each time interval. Okay, here this is mean or average velocity. We got it by dividing total displacement by total time duration. Yeah. Then we discuss few questions, how to take those things. So that is it. If we got a table like this, we have to find the velocities, and we can find the displacement and distances too. If we have two zeros like this at the end of the displacement time table like this, we have to know displacement. It is about the magnitude and direction too. So we have to think it has come to the initial position or the start position like this.
Okay,
I
teacher.
hope you can remember this one, this 0 and this 0. At the beginning,
Yes.
displacement is 0. At the end
In the
also,
end,
yeah, displacement is 0. At the
0.
end, yeah. So he has come, if it is a car, it has come to the initial position.
Yes.
This child has come to the initial position, but he has spent particular time by traversing particular distance. So we have a distance, but there's no
Displacement.
displacement. So that is it. Here we can tell that 8 meters to a particular direction and then back another 8 meters. So
50
total
meters.
distance is 16 meters.
16
Good.
meters.
Yeah. Here, when we take this region, we can find the velocity is 2 meters per second. Here velocity is 0 because there's no displacement at
Yes.
that time. But finally we have another velocity. But here we have to mention that it is in opposite direction. Here it is not mentioned correctly. What should we do to mention it as a velocity which is done at the opposite direction? කොහොමද අපි ඒක පෙන්වන්නේ? මෙතන ආන්සර් එකේදී. It should be written as minus 4ms minus 1.
Okay, teacher.
Yeah. Can you remember? I was telling that, but there's a printing mistake here. That's why I'm asking that again. That day I told you that here it is wrong, but it should be mentioned as minus
Minus
4ms.
4ms 1.
Right. Yes, that is the answer. That gives us an idea that it is moving backward in the opposite direction. Then we were discussing about acceleration and deceleration at the end of the class. So I was doing it fast because it is the end of the class at that day.
Yes.
So I'm going to tell you about that again. Acceleration. Acceleration means something, if it is a vehicle or if it is a child or any object, it going to increase its velocity. That means when the velocity is increasing, we can find the rate of the velocity increment or the rate of the velocity increase. The increase or decrease is a change, so we can write it as rate of change of velocity. Especially for acceleration, it's the increment of the velocity. ඒක වැඩි වෙනවා. Velocity is increasing. Here, you can see the time is mentioned 1, 2, 3, 4, 5, 6. Those are second. And then velocity is increasing. At first second, velocity is 2 meters per second, then 4 meters per second, then 6 meters per second. Yeah, in that way, velocity increasing. So we can find the acceleration here. To find the acceleration, what we have to do is we have to subtract initial velocity from the final velocity. And then we have to divide the answer by the total time which it has spent. Yeah. Here, final velocity is 12 meters per second. Initial velocity is 0 meters per second. Yeah. The time spent was 6 seconds. So our answer is finally 2 meters per second minus 1. Yeah. Here again my units are wrong. What about this -1? How it should be changed here? Here -1. Here there's another s. So what should be the number here? Instead of -1, there should be
-2.
-2 here, because when we take the units of acceleration, it is like this. We have to divide m is -1, then second. Our answer is m is -2, like this. Got it?
Yes, teacher.
Yes. So that's why it should be -2. And then in an acceleration like this, we can find the displacement done at that time interval. From 0 second to 6 second, that object has moved. That means it has done a particular displacement. But we have given different velocity values and time intervals. So what we have to do here is we have to use our equation for finding velocity. But here we have a problem. We have some different velocity values, not a single velocity. So in this case, instead of this velocity, we have to use mean velocity. How to find the mean velocity when there are some few values? From 0 to 12, we have different values. So what should we do to find the mean velocity here in this acceleration?
Again, initial velocity plus final velocity divided by 2.
Yeah, we have to add initial velocity and final velocity together and divided by 2. So then we get a mean value. That is the normal velocity. That is the in-between value of 0 and 12. So now we have 4 meters per second. Now we can easily find the displacement because we know the time. It is 6 seconds. We can easily find d is equal to 4 multiplied by 6.
6.
No, the 6 seconds. Yes. Here we will get 24 meters for the total time interval from 0 to 6. At that day, I have found what is the displacement within first 4 seconds. So that is the total displacement today for the whole 6 seconds.
Yes.
Okay. Now deceleration. It is same here. The equation is really same here because we are using the same equation for the acceleration too. Acceleration is equal to final velocity subtract initial velocity divided by total time. මොකක්ද මෙතන difference එක? What is the difference here? Our initial velocity is a big value, but final velocity is a
low value,
very small value. So we will get the difference between final velocity and initial velocity as a minus value. So here we will get for the total time interval which is mentioned here from 0 to 6 seconds, we will get minus 12 m is minus 1 divided by 6 seconds. Earlier we got a positive value here. Now it's a negative value. So our answer is minus 2m is minus 1. That is the answer. So that is the acceleration. So we have another different term here. We can use this term, but especially we have to remember when we are using this term, what we should do. We have to remove this minus mark here. We have to remove this. So to remove that, what we do is we put another minus in front of it. So minus into minus, finally we will get a positive answer. Yeah. So if there's a question in a paper, if it is asking us to find the acceleration in this kind of a situation, we have to put the answer as a minus value. But if they are asking for the deceleration, and another word for that is retardation. Normally we are not using it, but in a question paper, in a past paper, I saw that it is put as retardation. අපි normally මේ word එක use කරනවා අඩු වෙනවා retardation කියන්නේ. But this is not normally used for this lesson, but it has given. This is same for deceleration, retardation. Yeah, our answer is now it's a positive value. So it should be remembered. Then, is everything clear up to now?
Yes, teacher.
Yes. So our new friend, Senita. Hi, Senita. Can you hear us?
Yes, madam.
Yeah. Yes. Can you hear us?
Yes, madam.
Since I was, yeah. I think this is the first day of yours.
Yes.
Isn't it? Yes. So, Senita, I have to tell you that in this platform, you can, while you are logging to the website, you can download all the tutorials, which I am going to do. And then again, also at the end of the class, you will get a paper and you can put the answers in it. You can put the answers in a separate paper, or you can take a printout of that and you can fill the answers in it.
Okay,
By
madam.
doing that, you can take the photographs and upload to the answers to the website. Then I am going to check those things and I can re-upload it as a small recording. So shall I show you how to do it, how to log in and how to take your tutorials and everything? Shall I?
Okay, madam.
Okay. So this is your first step. We have to show that. Yeah. It's here. This is my profile. As a student, you can log in as a student. Here at the beginning, I show it. This is the normal look of the website. And in this part, you can log into the profile. Each student has a profile. With that, you can open the classroom, yeah, like this. Sorry, it's grade 9 and this is grade 10. පොතේ චුට්ටක් vibrate වෙනවා phone එක හොඳ. Okay, here you can watch the videos of the previous classes in that section, videos, and then here it is tutorials. You can have the first tutorial for the first lesson, and second one is for the lesson we are doing now. Then sometimes I can give some MCQs as the Google Forms. You can submit them after doing that. Until now, I haven't uploaded MCQs, but here I have uploaded 2 papers. One for the first lesson, and second one, second worksheet is for the second lesson. What we are doing now. Here, this is the first paper. You can download this PDF and take a printout and answer the questions here. Hari, this one. This is for the first lesson. And this is for the next lesson. That is this one, what we are doing now. You can take it and answer the questions by yourself. And then you can take the photographs and send, and that means upload back to the website. And I'll correct them and give you it as a small recording. But you haven't uploaded yet any answers. And there's one. So that is how it is going. Is that
Okay.
clear?
Yes, madam.
Yeah, okay. So today we are going to move to our next part of the lesson. Here we have question. Shall we try? Shall we give a try for that? You can take a separate paper or find the answers, and we can find whether it is correct or not. Before going to the question, can you tell me what should we do here? Can you both tell me how to find a body accelerate for 3 seconds and acquired a velocity of 12 meters per second and decelerate for 2 seconds and comes to the rest. Find the acceleration and deceleration. How should we do that? To find the acceleration, what should we use? Can you tell me? Can you both tell me how to find? මොකක්ද use කරන equation එක? Acceleration equals acceleration means the velocity is increasing. Initially, here it is not clearly mentioned that it is if it is at rest or not, but assume here it is starting from the rest. That means initial velocity is 0. Then the acquired final velocity is 12 meters per second. Then how to find the acceleration here? We can use this equation. Can you both find both acceleration and deceleration? Silent, why? Is that difficult? Then let's try together.
All right.
Okay. Will you give a try? Okay. All right. Presentation. Fine. How to find? Acceleration is final velocity subtract initial velocity divided by total time. එතකොට මේ first එකට acceleration කොහොමද ගන්නෙ? Final velocity is first part of the movement, first part of the motion. Body accelerate for 3 seconds and acquired a velocity of 12 meters per second. Then Substitute everything here. Final, what is the final velocity here? Okay, then let's have a look. What about this? Final velocity is 12 meters per second. Initial velocity is 0 meters per second. What is the time? 3 seconds, isn't it?
Yes, ma'am.
Yes. Okay, the answer is 12 divided by 3. Our answer is 4 ms minus 2. And again, I have put it as, it should be 2 here. Okay. Then to the rest of the motion, we have this. Acceleration equals 0. That means the final velocity at the end. And initial velocity is 12. So 0 minus 12 is minus 12. Minus 12 divided by 2 is minus 6 meters per, again, square second. Always it has put as minus 1. Then our answer is deceleration. It should be put as a deceleration. So we have to put it as a positive value. 6 ms minus 2. That is the deceleration. So we will get acceleration and deceleration at the end. Is that clear?
Yes, teacher.
Yes. But you were silent at the beginning. Why is that? Is that difficult? Huh? Is that difficult?
Now it's clear, teacher.
Now it's clear. Okay. So you have to remember it like this. It's really easy. You have to divide the velocity difference by time. We will get acceleration. If it is a decrease of velocity, we will get deceleration. That is it. So today we are moving to another new part of this lesson. That is graphs. In this lesson, we have to learn about different graphs which are expressing the motion of different objects. Here there are two graphs we have to study. First one is displacement time graph. Second one is velocity time graphs. Here at the beginning I am going to tell you about displacement time graphs. Here displacement time graph means we are plotting the displacement against the time. It is a graph which has plotted by marking time on the x-axis and the displacement on the y-axis. So here in this graph, you can see time is mentioned as 1, 2, 3, 4, 5 seconds. A second by second time is marked on the axis, on the x-axis. And in the y-axis, on the y-axis, we can see the displacement is marked. It is 3 by 3. 3, 6, 9, 12, 15 meters. Here it is seconds. Meters and seconds. We know this. We know this from the beginning because we have learned about the velocity. That is our equation for velocity. And with that, we know that displacement is given by meters and time is given by seconds. Sometimes it may be kilometers per hour. Here it is mentioned as meters and seconds. So here you can see in the first second, it has done a displacement of 3 meters. So 1, 3 and 2, 6. these are the coordinations of this graph. This graph is plotted by using these coordinations. Normally these coordinations are given to us in a graph, in a table like this. Time is given in this way, and time is given in seconds, and displacement is given in meters, and these coordinations are mentioned in this graph. Here it is in this table. Here is 0 at the beginning. That's why it is 0 here, 0, 0. And 1, first second, it is 3. That is mentioned here. That is next coordination. And 2, 3, 4, 5. In this way, it has mentioned here. 3, 6, 12, sorry, it's 9, 3, 6, 9, 12, and 15. Can you see this? Everything has come to the graph. Each and every coordination, each and every information mentioned in this table is in the graph. 1, 3, 2, 6, 3, 9, 4, 12, and 5, 15. Those are the coordinations. So here, this is a normal view of a displacement time graph. When the displacement is increasing with the time against the time, we can draw it like this. We can see it is increasing. Time by time, second by second, it is increasing. But we have some different shapes of this graph. Look at here. Here displacement is increasing with time. So here here we have to discuss another new thing. I told you that we have to think about this equation for the velocity when we are using this displacement time graphs. The reason is, in a displacement time graph, we will get the velocity as the gradient of the graph. When we take the gradient of this graph, actually it is the velocity. This is the gradient. So here when we take the difference between two y coordinates and divided it by the difference between two x coordinates, we will get the gradient of the graph, and gradient gives the velocity. So here, to find the velocity, we can use this b and a. That means this coordination and this one. I am selecting this one and this one, which is at B and which is at A. So if we consider this as a triangle, to find this angle, we have to divide BC by AC. That means BC is the difference between the coordinations in y-axis, and AC means the difference of the coordinates between this x-axis. Here. Okay. Here, to find this angle, we have to divide BC by AC. BC is 15 minus 3. So it is 15 minus 3. That is the difference between y coordinates. Divide by difference between x coordinates. In x-axis, it is 5 and 1. So we have to subtract 1 from 5. We will get here 12 divided by 4. 12 divided by 4. 12 is in y-axis. That means it is a displacement value. The unit is meters. So we have to put here meters, the units too, we have to put the units too. At the first steps of the substitution of each and every value, we have to put the units. It's really important because in the exam, sometimes we are getting some marks for the units too. If our answer is correct, even though our answer is correct, we can get some marks if we have put all the numbers and units correctly. So here it is second. Then meters divided by second, we know that is the units of velocity. So we will get a velocity value, 3 meters per second. That is the answer for the gradient of this graph. So you have to remember, for a displacement time graph, by its gradient, it gives us the velocity. We are plotting the displacement done at a particular different time intervals. But we can find the velocity by using that graph. That is the thing. That is the gradient of this graph. Is that clear to both of you?
Yes, teacher.
Yes.
Yes,
Okay.
madam.
Yes. Okay, now we are moving to the next slide. It is again about few different shapes of the displacement time graphs. Yeah, it's here. So we will get we have the initial graph. It's a normal thing we know. Displacement is increasing with the time. And here, second one. In the first one, we have to remember it as a uniform or constant velocity. That means the velocity is not changing. If we are looking at a graph, we have to identify the same gradient at each point of the graph. It is always same. First here we took this final 515 and 13 coordinations. Here we get 3 meters per second. If we take this one and this one, again we get the same answer. So I'm going to put it here too. Here I have to get this one and this one. That means this one and this one. And here, this one and this one. So the difference between the coordinates in y-axis is 6. And here we have to put it as 15 minus 9. Again, the same thing, there's no difference. But I am telling this to show you that it is same at each point. The gradient is same at each point. Here 5 minus 3. 5 minus 3 seconds. Here it is 2. So our answer is 3 meters per second again. Did you understand that one? It is always same in this kind of a graph. Here 3, here 3, in that way. It is 3, 3, 3 in that way. This is a y equals mx type graph. So m or the gradient is same at each point. So we call it as a uniform or constant velocity. And what about this graph? Does it have a gradient? In in second one? Is it having a gradient? That means difference between y coordinates divided by difference between x coordinates. Difference between x coordinates are there. If we take these two points, we have difference between x coordinate. That means the time is spending. Assume it is 6 seconds. 6 seconds. So time is going, time is passing, but does it moving? Is it moving?
No, ma'am.
No. If we take this as 6 meters, the displacement, it is same. That means that is staying at a particular point. It is not moving. So when we get a displacement time graph like this as a parallel line to the x-axis, we have to remember that displacement is constant. It is not moving. That means it is at rest. It is not moving. That is it. So the second one. මොකද මෙතනදි වෙන්නේ? What's happening here? What happened to the gradient? What is happening to the gradient? Is it same at each point?
No.
No, it is not same. Here it may be another value. Here it may be another value. Here it is larger than this one. So always the gradient, that means the velocity, the gradient of the graph is always increasing. That means velocity is increasing. What is the what is the term we are using for the increase of velocity? When the velocity is increasing, we call it as an acceleration. So acceleration, it is an acceleration. When we get a graph like this as a displacement time graph, it is an acceleration. So sometimes we will get an opposite of this. We will get something like this. So here it has a high velocity, high gradient at the beginning. Then it has a lower value than that. Finally, it has another lower value. Finally, there's no gradient. That means V equals 0. That means it is staying at a particular position. Here gradient is decreasing, so this is a deceleration. This is a deceleration. Okay, you have to remember this too. This is not in the book, but sometimes it comes to the exam. So in 2020, that means the previous paper, we got a question like this. But this is not well mentioned in the textbook. So it is important, but it is not difficult. We know that gradient of a displacement time is velocity. I think if the gradient is increasing, velocity is increasing. We know it as acceleration. When the velocity is decreasing, we know it as a deceleration. So we can identify these two graphs if we are given something like this. එතකොට මේවා එකතු කරලා ඉන්න පුළුවන්. There should be a combination of this kind of graph. Sometimes like this is a uniform velocity or a constant velocity, and sometimes it has rest and it is accelerating, and again velocity is increasing but in an opposite direction. So now I am going to mention this one. This is our next graph. Displacement is reducing little by little. Initially it was 8 meters and then it was 6 meters and then it is 4. In this way, displacement is decreasing. That means if we take two positions as A and B, here between A and B, the straight line distance is referred to as the displacement. So that means if it is 8, then it becomes 6, then it becomes 4, then it becomes 2, finally it becomes 0. So in this way, here this distance is too much comparing to this one, but it should be same. So when the displacement is decreasing like this, we have to remember that it is moving in the opposite direction. If we consider this direction as AB, අපි මේ AB direction එක consider කළොත්, here the displacement in this direction is decreasing. It means it is moving back. It is not in the AB direction, moving in the BA direction. So we will get something like this as the graph. Earlier, it was increasing like this. Displacement increasing. Now it is coming back. So for a movement like this, අපි හිතමුකෝ some one person starting to move in a particular direction like this. It moves up to 6 meters. This is displacement. This is time. So here he moved 6 meters and came back to the initial position. This is like a table we have made. Displacement time data table. That is same. T and here D. D is starting from 0 at 0 second, and finally by the time it goes to 6 meters, and finally with the time it has come to the starting point. That is how it happened. Here we can mention some few time intervals, 2, 4, 6 like this, and that is the normal thing. It's a combination of these two graphs. Move to somewhere and coming back. Move to somewhere and coming back to the initial position. Finally, the initial displacement is 0. Again, final displacement also 0. Got it? Is that clear to
Yes,
both
madam.
of you? Yes, okay. To both of you?
Yes, ma'am.
Yes, okay. That is how the displacement time graphs. Normally we will get each of these shapes in exam as a small question. I show you a little question like this. This is that. This is a normal displacement time graph. In question, they are asking us, we have to comment. Actually, this is a this is an MCQ question, but I couldn't have the paper, so I type it. So here you have to tell what is the movement from 0 to T1 and T1 to T2. There are 2 time intervals. We have to tell what's happening in this first part and what is happening in this second part. Then what is the movement mentioned in this first part? Is it a constant velocity or at rest or acceleration or deceleration or moving in opposite direction? What is it?
It's acceleration.
It's a, I couldn't hear that clearly.
It says accelerating.
Here we have to think it's a displacement time graph, not a velocity time graph. Displacement time graph is having a gradient which is equal to the velocity. Can you remember?
Yes, ma'am.
Yeah, so this gradient is equal each at every point from 0 to t1. එහෙනම් මොකක්ද මේ? What is this? It's a, it may be an acceleration if it is a velocity time graph, but here displacement time graph. What is given by its gradient? What is the answer given by a gradient of a displacement time graph? මොකද්ද මේකෙන් දෙන්නේ අපිට? What is given by this gradient? M divided by S. What is it? Displacement divided by time. What is it? Meters per second. What is the quantity having these units?
Meters per second.
Yeah, meters per second. That means velocity. Velocity. Now velocity is constant. Gradient is constant. Then what is this motion? What kind of a motion is this? It's a constant velocity. Can you get it?
Yes.
Yes, it's a constant velocity. So we have to select this answer as the constant velocity. It's a constant velocity. So here, so please remember this. Normally when we are having a graph like this, when a graph y equals mx graph, we eventually tend to tell that this is an acceleration. Actually, we have to look at the title of the graph clearly. Displacement is there. Displacement is the thing which is going to be increasing. It's a velocity. Velocity. The gradient is velocity. So please remember this. This is not a VT or so it's a D against T, displacement against time. So second one, this shape. Now what is going to happen? What is going happen to this gradient? Is it decreasing or is it increasing?
Decreasing.
It is decreasing. Good. So velocity is decreasing. Now you can tell what is it. When the velocity is decreasing, we call it as a, what is that motion? What is that? What is that motion is defined as the, now you can tell it if it is an acceleration or deceleration. What is it?
Deceleration.
Deceleration. Good. So gradient is decreasing, it's a deceleration. It's a deceleration. So it's a combination of two graphs for constant or the uniform velocity and deceleration. If it is an acceleration, this graph will give us something like this. It is increasing like this. But we have given a deceleration. So That is it. We were there discussing about the displacement time graphs. I hope now you can remember these things. Clear the Medica? Is it clear?
Yes, ma'am.
Yes. So I am moving to another question. So normally we will get not just one part of a graph like this. We will get few graphs connected together, few shapes connected together. So it's something like this. We will get a graph like this in exam as a displacement time graph. So here we will have to remember, especially we have to remember to look at the graph title. Here displacement is mentioned, here it's as a displacement. So normally in exam we will get confused about the displacement and velocity. අපිට පැටලෙනවා. අපි එකපාරට දකින්නේ. So we have to remember it clearly, whether it's a displacement or velocity difference here. So here it's a displacement time graph which shows the journey of a woman going to a corner shop and coming back. So here, this initial part of the graph, it's a constant velocity, and velocity, the displacement is increasing. She is going to the shop. The first part of the movement is like this. Here this is the woman and she is going to a shop like this. Here we have some distance. What is the distance or what is the displacement she has done? We have to assume that she is going along a straight line path because the displacement, that is a displacement. පොඩක්වත් හැරෙන්නේ නැතුව she is going along a displacement, that means along a straight line. So what is this distance to the shop?
60.
60 meters. She has moved 60 meters. And then how much time did she has spent
30 seconds.
to that? Yeah, it has taken 30 seconds to go there. And what is the time interval she has spent there in the shop, staying at rest in that shop? 60 seconds for how much time? Displacement is constant, 60 meters for how much time?
90 seconds. 120 seconds.
120
seconds.
seconds. Here we have to think about it little bit. Yeah, she has taken 30 seconds to go there. From here, initially displacement is 0. She is at the house and time is 0. Time is not counting it. Now she is moving little by little to the shop. It is 60 meters to this point. And we can see here, we have to look at carefully this one. From here to here. Is the displacement changing?
No.
No, that means she has spent there this time interval. This time interval given by this. What is it? What is the difference between 50 and 30?
20.
20, good. 20 seconds. She has spent there 20 seconds without coming back or without going further. 20 second spend කරලා තියෙනවා shop එකේ. And then she has started to come back. She has taken something and she has started to come back. Then we can see this is given by this. Again, 60 seconds is moving, but in the opposite direction. We got this kind of a graph for the objects moving in opposite direction like this. So that is that the meaning of that, he is going there and coming back like this. So when we look at this, this is a small angle. It's a small angle, but this angle is larger than the previous angle. We know that this angle or the gradient of this graph, of this displacement time graph, the gradient gives us the velocity. The difference between the size of this angle gives us an idea about the magnitude of the velocity. Here we can see it's a smaller velocity. Here we can see it's somewhat large
Bigger.
velocity. Yes. So here, but she is moving in the opposite direction. Yeah, she is coming back. She has spent another 20 seconds for that. She has spent 30 seconds to go and 20 seconds to come back. After taking things, she is coming back very fast. So by that time too, we can get an idea that she has moving faster than before. Initially 30 seconds. First she has spent 20 seconds. So if she is spending less time, she is moving fast. That is the meaning. So it is given by the gradient of our graph too. When we look at the graph, we will get a larger angle, but here it's a smaller angle. So when we look at the gradient of this graph to find it, to calculate it, we will get answers like this. Velocity equals the gradient of the graphs. When we are given a graph like this, we can't just put velocity equals displacement divided.
Hello.